In this example, I want to take a look at the area of the region bounded by the graphs of the given equations. And we have the equation y equals x plus 2, y equals x squared. So there's a couple things that we got to take care of before we really jump into the calculus side of things. First thing we need to take care of is figuring out where do these two graphs intersect one another? Like what are my limitations of integration? Like where am I going to be going from? Am I going to be going from -5 to 1, -2 to 3, 1 to 5? Like what is happening here? A couple different ways you could do that. You could do that on your calculator where you just graph them and then use the intersect function. That's one way. Another way is setting them equal to one another. And I'm going to go ahead and just go with this algebraic route. Set them equal to one another, and then solving it. So let's subtract x, let's subtract 2. So I have 0 equals x squared minus x minus 2. Because I'm setting them equal to one another, so what I'm wondering is for what x values will this be equal to one another? So I'm going to now factor this. I want two numbers that multiply to a -2, add up to a -1. That's going to be x minus 2 and x plus 1, right? -2 times 1 is -2. -2 plus 1 is -1. Checks out. All right, so now we're going to take both of our factors. X minus 2 equals 0. X plus 1 equals 0. So we get x equals 2. So I add the 2 over. I subtract 1. X equals -1. So they're going to cross paths at -1 and 2. So we now know our integration limits. So we're going to integrate from -1 to 2. Cool. Now, next is we need to figure out, is it going to be x plus 2 minus x squared? Or is it going to be x squared minus x plus 2? Like, which one's on top and the bottom? So top minus bottom is how we want to look at the area of the region, bounded by the graphs of these two given equations. So which one is happening here? Two different ways to do this again. First way is understanding just what does these graphs look like. That's one way, just understanding properties of graphs, and if you have pretty good knowledge of that. Second way is graphing them and then seeing which one's on top, which one's on bottom, so which one would we be subtracting. So if we just think about this on a graph, so if I have -1, yeah, -1 to 2. So it would look roughly like this. So let me actually. So that'd be x plus 2, just about, just a rough sketch. And then that would be x squared. Sorry. That would be x squared. So it looks something like that. Not the best sketch, but you get the idea that from this limitation of -1 to 2, where they cross paths, x plus 2 is going to be above the x squared. I'm not satisfied with that x squared. Let me try one more time. I keep on there. That's a little bit better. Okay. That's as good as it's going to get for now. So that's x plus 2, and then that's x squared. So you can see that from -1 to 2, x plus 2 is above the x squared. So we're finding the area of this region here bounded between these two graphs. So that means we want to do x plus 2 minus the x squared. And then from here, it's just an integration exercise. So we are going to do, let me try to keep this clean, x squared over 2, integrating x, that becomes x squared over 2, plus 2x minus x to the third over 3. And this is from -1 to 2. I'm going to go down here. So I'm going to have 2 squared over 2 plus 2 times 2 minus 2 to the third over 3 minus, and then we got to enter in -1 squared over 2 plus 2 times -1 minus -1 to the third over 3. definitely have to be careful here. So when you type all this in, you're going to get, so I'm just going to do this in chunks. So for this first chunk right here, this is going to be 10 over 3 minus, and you really just have to know your calculator and stuff like this. Like, this may seem very like, oh, this is silly that we're sitting here talking about entering this in, but if you're not careful with entering in -1 squared and you want to subtract it all off, that's why I just do chunks like this. You never know, like if you just mistype something and your calculator interprets it a little bit different than what you typed it in as, like, it just becomes a mess. So just take your time with it, figure out your calculator. But for this second part of it, you should get -7 over 6. So then we're just doing 10 over 3 minus that answer, and you get an answer of 9 over 2. Believe it or not, I would assume if you're going to make a mistake somewhere, it's probably going to come here, to be honest. Like, I really do. If you're going to make a mistake somewhere, I think that calculator and the minus, with all those negatives, and if you're not careful, you could really make a mistake there. But other than that, it's just setting these two equal to one another, figuring out where they intersect one another. You can use your calculator for that. I just went with the algebraic approach in this video. And then figuring out which one's above, which one's below, subtracting that order then. So the top one, x+2 minus the x squared, and then it's integration. So if you're pretty strong with integration, it's pretty straightforward from there. But you really want to be careful on this step there. So you get answer 9 over 2.